Welcome to the today's Leetcode daily challenge. So let's see the problem. Given a n grid, n into n grid containing only values 0 and 1, where 0 represent water and 1 represent land, find a water cell such that its distance to the nearest and land cell is maximized and return the distance. If no land or water cell is exist in the grid, return -1. Okay, so we are given a matrix, a grid which contains land and water, where 0 is water and 1 is land. So we have to find a water cell which has the maximum distance from the nearest land cell. Okay, so let's take the example, and the distance used in the problem is Manhattan distance. The distance between two cells is this. So let's take an example and draw its matrix. Then let's see what question is asking to us. So this is a grid given to us. So first let's draw this. This is something like this, where 3 into 3, it's a 3 into 3 matrix, 3 into 3 grid, and 1 is land, 0 is water, 1 is land, 0 0 0 1 0 1. So 1 here is the land and 0 is the water. So let's see how much minimum distance is every water cell from nearest land cell. Its nearest land cell is this one, so its Manhattan distance is 1. That is different of one column, or we can say one x-axis, and from also this side it's 1, so its minimum distance is 1, and its minimum distance is also 1 on both sides. It's also 1, it's also 1. So let's see this one is left 1 2. Okay, so its minimum distance is 2. So all over the water cells, the maximum minimum distance from the land cell is 2. So our answer will be 2. Okay, so how can we calculate that? A brute force approach I can think is that I will just run 2 loops, and from each water cell I will start searching for the nearest land cell, and then I will continue. So this will give us a time complexity of n square for searching over the iterating over the whole matrix, and another n square for starting from each water cell. So this is give us n to the power 4. So this will give us TLE, because the constraints of this problem are 100. This will run. No, this will not run, because 10 to the power 2, this will give us 10 to the power 8, it will give us TLE. So this won't run. So we have to think of a better approach, that is a n square approach. That will work fine for us. 100 into 100. So how can we do that? So one observation we can see in this example itself, that it is 2 distance from its nearest one cell, but from its 0 nearest water cell it is at 1 distance, and its value is 1, already 1. So 1 plus 1 2. So you got it. We can think of a DP way, in which at every 0 index we will store its value, DP value. Or we can also think of something else. We will simultaneously start our iteration from each one cell. So all of them are iterating simultaneously level wise, and after traversal, after one we will simultaneously travel, so that after one traversal we will be able to travel many levels from each of the land cell. That means that we will simultaneously start traveling from this to left and this to right, simultaneously from this to this and this to this, this to this and this to this, so that it reduces our time complexity. We won't have to go to each one of them one by one. We will start from itself. So we will start from the land cell, not the water cell. From the land cell we will calculate the minimum distance of the nearest for different water cells from each land cell, and then after that we will travel over the whole matrix and return the answer. So how can I do that? I can think of a BFS, because BFS gives us the shortest distance. So from each land cell, we will be able to calculate the shortest distance of the nearest water cell. So, but there are many land cells and water cells. How can we do that? We can do multi-source BFS. So we will take a queue, and in each queue we will put our ones for each column and row, for each position, and then we will do a level order traversal, so that we will be able to mark our water cells. So the maximum level up to which our BFS will go is our answer. So let's do a dry run. What I'm trying to say to you. We will maintain a queue in which we will add. So this is our matrix. This is the matrix. Let's quickly fill it. 1 0 1 0 0 0 1 0 1. So put this in queue, put this in queue, put this in queue, put this in queue. So let's go here from our first iteration over the queue. Go here, go here, go here, go here. So these all are marked, and all of its distance will be 1. So we will mark all of them as visited and convert them into the 1 and put them into a queue. So let's now we will go to the second iteration, where this and this is in our queue, and their respectively distance from the nearest one is 1. So we will try to search for their neighbors, this, this. So their value itself is 1. So its nearest neighbor, which is unvisited water cell, it's 1, is it's here. So 1 plus 1 is 2. So that's how we'll be able to do that. For each cell in the queue, we will visit its 4 neighbors, and if it's not visited, we will put it in our queue and increment our count, increment our distance from the land cell. So the maximum up to which the queue will be able to go is our answer. And how will we mark them? We will just convert 0 into 1 in the matrix itself, so that we won't visit it again and again. And we will, for each one in the queue, we will see its 4 neighbors. If it's valid, if it's water cell and not visited, we will add it to the queue. So let's now code this. And how will this work in n square? Because at max we are only traversing the whole matrix, which is n into n. So we are just using extra memory. So we are doing a time space trade-off. We are using extra memory for our time. How much extra memory can we have? So our space complexity for this is also n square, because in worst case scenario all of the matrix could be land cell itself, so queue would be filled. So its space complexity is also big of n square. So let's now code this. So first let's mark it boundaries. Okay, it's not matrix, it's grid. And let's maintain a queue, where queue will store the in x and y axis of the matrix, that is I and j cell, which indicates the position of the cell. Okay, and where answer is 0, this is our farthest, this is we will return this as answer, where answer is the farthest distance up to which we can go while traversing all over the grid using using BFS. We will do level order traversal. So first we will do is that we will push all our land cells in the queue, because at each each traversal of the queue we will visit its neighbor, so our level will incremented by 1. And how will we able to visit all its neighbors, that is fall neighbors? We will maintain something like this. So let us now start the BFS. We will traverse over one level inside the queue. This is the top front element of the queue, so let's not pop it out. Also we will visit all its neighbors, and that's how we will be able to do that from the above x and y array I created. So that's I'm not going to explain you the syntax, because we are storing I and j as a pair form, and here we are going accessing that and visiting his neighbor. So basically this, so what I'm doing here is that, so let me try to explain to you. If I am this cell, I can visit this, this, or this is not valid, so we have to check for not valid also. And what's its distance? This difference of y-axis, 1 y-axis, a difference of negative 1 y-axis, negative x-axis, a difference of positive x-axis, a difference of positive x-axis, a difference of negative x-axis. That's what I'm doing here. So okay, and if it's valid, I will push it in my queue. And what will I do is that I will mark is as visited. And how I am going to mark it as visited? I am just going to convert it into a land cell. Got it? A land cell. And how I am going to check if it's valid? I am going to maintain a valid function which will take I, j, n, m. No, it will take. So this is just checking for the conditions. And it should be a water cell, not a land cell. So this we are using AND because if even one of them is failed, it won't move further. So let's now just quickly do it. Okay, mistake. So let's now see if it's working or not. I think it should work, but why it's not working? New x, new y, and new y. Where is? Oh god, I did a mistake. Typo error. let's see if it's working or not. Okay, why it's not working? Why is my answer returning 3? Okay, what I'm doing is here I have put them in my cell, so I have incremented 1. Okay, and then I waited here, so my count become 3 2 count become okay, I got it I did a mistake. I have to subtract 1 from my answer, because the level I'm getting is not of my end cell, it's of next, it's of neighbor to it, so we have to do subtract -1 from it. So let's test it, and its time complexity of this code is big O of n into n, and space complexity is also big O of n into n. So let's start to submit this. Okay, where I'm getting the error? Okay, if all of them are 1, I'm getting 0. Oh, I misread the question, so I should return -1. Okay, so I can do it that I can check for queue size. If our queue is completely filled, that means that we can't reach any water cell, so we will return -1. Okay, so this is our Leetcode today Leetcode daily challenge.